Hello everyone, my name is Jason. Today I'll be showing what I've done so far with fine-tuning Gemma 3N using the Walking Awareness dataset by Zhiqiang Yuan et al. In March 2025 to provide a detailed guidance on navigating the route for the visually impaired person. So I'm mainly referring to the provider Unslov Vision Fine-Tuning Notebook Guide as the pipeline and modify it for my training and inferencing. So let's get started. So firstly, I will install the necessary dependencies for Gemma 3N such as the unslog and the specified version of the transformers library, which is 4.53.2. Okay. After that, I will load the Gemma 3N E4B instruction tune model from unslog into the Kaggle notebook. So commonly, before fine-tuning the foundation model, I will prefer to check the original responses from the Gemma 3N first, and we can choose between audio, image, and text format for initial testing. So here, for example, we can take one of the sample image here, and we can see that this is a sample of image of a street. Okay, so we just let the model to try to analyze the image based on the instructions we given, such as can you describe the basic visual information of this image, provide detailed overview of surroundings, and provide guidance based on your analysis. So these instructions will be used after fine-tuning for the inferencing part. Okay, so the model is able to generate a very detailed description of the scene, but without proper guidance or reminders on how to navigate the obstacles along the road. So therefore, we will use LoRa low rank adaptation for the fine-tuning part mechanism and specify the reference parameters, and then train the Hugging Face dataset that converted from the original WAD dataset with SFT, which is supervised fine-tuning. Okay, so this is where we input a text question the and let the model to answer. And for this one, we have one sample audio for the model to try to analyze the contents as well, and we can combine all the three modalities for fine tuning. But in this case, we only fine tune the vision vision part of the model. That's why we will turn on the to train the fine tune the vision layers. Okay, so we will load the Hugging Face dataset that I created from the original WD dataset, which is shown here. Okay, we will have the image. Okay, we have the image and we have the scene summaries, which is a description. Okay, and also the reminder where this is our desired output, the reminders that navigate that tries to inform the orientation and the layout of the obstacles in terms of the scene. So as you can see here, this is one of our test image here. So we will then craft an instruction that asks an VRM to be an expert assistant for the blinds. Okay, so we will follow this format for the uh, vision fine tuning, and then after that we will try to infer the model once with the same instructions that I described above. Okay, so initially it is still a lengthy response. So right now we're going to train the model with the SFT. All right, so after that we can see that the model training loss is getting lower in the end of the training. And here we infer the model once again, such that it will give a very shorter response for now. So which is so of course probably we have to provide more sufficient data for the model in order for the model to learn uh, better and understands the understands the user requirements. So in the end, we will try to export the model into something some supported format, for example, like the GGUF format. So here, we will save we will try to export the model to my Hugging Face account, which is shown here. So in the end, we can also save it as plot 16 or GGUF, but in this case, I've saved it as a GGUF format. Okay, so for this part, let me just show you something. So this is the paper. So this is the original research paper for the WAT dataset, and here is the website. Here is the website that I use for converting LoRa adapters to GGUF. And here is the website that I use to convert the model into the GGUF models. So in the end we will get so in the end this is the what I got, the GGUF model, and here will be the three models that I have. This will be the original Gemma 3N, and this one will be the fine tune, and this one is the fine tune converted into uh, GGUF format with the quantization that I required. Okay, so let's so as a conclusion, as we can see here. Okay, so as a conclusion, you can see here is that after the fine tuning, we are able to it is possible to fine tune our models of response to satisfy the requirements of route navigating by providing good training dataset and the desired reminders. Thank you. I hope you enjoyed the presentation video.